We're looking at section 6.4. It's page 81 in your workbook, multiplying polynomial expressions. We're first going to start by multiplying a polynomial by a monomial. So 6.30 is what we're on. This one's a pretty quick one, just a couple pages. So I'm looking at a 3xy squared times negative 5 x squared y cubed. So for this, we don't distribute over multiplication. That's something to keep in mind. Once we do the binomial times the binomial, people tend to want to distribute where they shouldn't. So there's no pluses and minuses in between here. It's kind of similar to if I had like a 2 times 3 times say 5, I would just go 2 times 3 is 6 times 5 is 30, or I could do it as 2 times 15 is 30, right? But I would never go 2 times 3 is 6, and then 2 times 5 is 10, and then somehow suddenly either multiply or add those together. That wouldn't make sense. So the same thing here, we're just going to multiply our coefficients. So it's really like this, 3 times the negative 5. Then I multiply my x's, x to the first, x squared, is x cubed, and then we have our y to the 5th, right? Y squared times y cubed is y to the 5th. So we're using our exponent laws, and then I do need to calculate this out. Negative 15 times x cubed y to the 5th, and that would be my answer. So notice there's no pluses that got added in there or anything like that. So careful of how you write your answer and what you're doing, and making sure you're completing this same process as modeled in videos and as is appropriate to the problem. Now B, we have a situation where we are going to distribute because we distribute over subtraction. So we have a multiplier here, 3, so that would be 3 times m, and then just bring down our minus. 3 times 4 is 12. So that is somewhat review for you. It should be review. We've done that at the beginning of the course. It may have been kind of a while. I'm doing some other things in between. So just to reiterate those concepts for you. Now we're going to do some more complicated ones with some different exponents and fractions. So you can pause the video and try these on your own now that you understand the concepts, or just follow along with me. So now here we have 2x squared times quantity x squared plus 3x plus 5. So I need to distribute because I have pluses in there. So I'm going to multiply 2x squared times x squared will be 2x to the 4th. Bring down my plus. 2x squared times 3x is going to be 6x cubed. Sometimes writing that exponent of 1 in there helps, because I would say that's the common mistake. I see that people just kind of forget about that one or think it's 0, but it's not. Anything to 0 would be equal to 1. And then we have, bring down the plus, 2x squared times 5 would be 10x squared. So that's it for that problem. Now the next one is a little trickier. Again, we're going to distribute, but we have some fractions to deal with, and we do want to reduce our fractions ultimately, but I'm not going to do that until the next line, because I think that's just adds in one more thing to have to do in your head. If you can do it while you're going and you're accurate, then that's totally fine. So we have a half times 4/3 will give us 4/6. Then y to the first times y to the first would be y squared. Z cubed times z to the second is z to the 5th. So I just kind of take them separately. Now I bring down my plus. They're still all multiplied together, but I do kind of each piece so I can track it. So then I have half times 8 is going to be 8 over 2. Again, you could just calculate that as you go if you want. Y to the first times y to the first is y squared. Z cubed times, there's no z's over there, so it's just z cubed. Bring down your plus. Then half times a quarter is an eighth. And then we don't have any variables there, but we need to bring these over. The yz cubed. Now I'm going to reduce, so I have 2/3 y squared z to the 5th plus 4 y squared z cubed plus 1/8 y z cubed. And that is my answer. Now we're going to look at page 82 of the workbook. Multiplying with binomials. Example 6.31, multiply and simplify each expression. So we have to distribute to every term. So we're going to do the first term on each set here. So that's called our firsts. You may have seen this before if you've had some kind of algebra at some point. 2y times 5y would be 10y squared. Now make sure you get that square exponent. Again, put that 1 there if you tend to forget that, because you're adding exponents and those are not just to the 0, right? If it were, they wouldn't be there as y. So make sure you get that. That's probably the most common thing that'll throw everything off. Y times y is always y squared. Then I'm going to do my outsides, which is this. So I'm just going to now distribute this 2y to the second term in the binomial on the other binomial. So I would have 2y times 6, and it's positive, so watch your signs there, plus 12y. Now I'm going to use a different color here, and I'm going to do my insides. That's what we call that. So I would have -3 times 5y is minus 15y. And then I'm going to do my last, the last on each binomial. And that is -3 times 6 is going to be a minus 18. Okay, so here we have our first, our outside, our last, and just, include the sign as you work with it. Oops, sorry, our inside and our last. And you may have seen this, it's called FOIL. Okay, so we have FOIL. And I'll just write in here, this is first, outsides, inside, or firsts, right? Insides and lasts. Okay. So we're not quite done yet though. We need to simplify, if possible, by combining like terms. So on the last step, the 10y squared plus 12y, I'm going to want to make it be 12y minus 15y, and that will give me a minus 3y, which I'm actually just going to write as minus 3y. And then my minus 18 just comes down like that. So that's my completed answer. I always want you to think how things would work if we had to go backwards. What if we have to undo that and get from here back to here? How would we do that? Look how this splits apart. Like I have to find combinations of this middle terms to that add up to -3y. So that's a little tricky. So I want you to try to think how when we're going forward, how we would go back and undo that, and call it, I don't know, we could call it backwards distributing as factoring. So this is my final answer on this one. Don't try to reduce it or anything else. Simplifying was just combining the middle terms. Okay. Now I'd like you to try to do B as a classwork if you're comfortable with it, because it does have variables at the end, but just treat them the same way. Just follow your process. You know how to multiply variables. So pause the video and give that a try, and then I'll go through it as well, but you can skip through if you get the correct answer. The correct answer for that one will be 4y squared minus 7 yz minus 2z squared. So make sure you write out all your steps though. Okay, so now I'm going to do my firsts. 4y squared. My outsides are minus 2z times 4y, so that'll be minus 8z y, or actually I'm going to write it as yz to keep in alphabetical order. And then I have my insides, which is a plus yz, and my outsides, so get rid of that, z times negative 2z will be minus 2z squared. Then I have to combine my like terms here. 4y squared minus 7yz minus 2z squared, which is the answer I gave you earlier if you were just doing classwork. But those are the steps there. So I hope you find that helpful. Remember here, this is my first, my outside, my inside, and my last. Now you could actually do it as file. It doesn't really matter if I end up with this yz first and then, you know, minus the 8yz, you'll get the same answer in the middle term. So it could be FOIL, it could be file. You could even totally mix it up to be, you know, LOIF, LIFO, whatever. But we often want to just keep a pattern and be organized with it. So that's the purpose of that, an acronym, just to help you. But what we're doing is distributing every term to every other term in the other binomial. So every term in one binomial or polynomial, the case may be, like with this one, you know, has to be taken care of. So this is a little bit trickier. We have a binomial times a polynomial. So we're not going to use FOIL because, yeah, we got more to do. So we're just going to distribute every term, or I'm going to take the first term in the binomial times every term in the trinomial. Then I'm going to do the second term in the binomial times every term in the trinomial. And again, pause the video and see if you can do this on your own. So I have 2x times x squared. Actually, let me read the full thing, so in case someone needs to hear that. So it's this problem to begin with is 2x plus 3 in parentheses times parentheses x squared plus 5x minus 1 end parentheses. So I'm doing 2x times x squared to get 2x cubed. Then I'm going to do 2x times 5x, and I'm going to get plus 10x squared. Then I'm doing the 2x times the negative 1, and I'm going to get negative 2x. And I'm just going to keep going across ways. And I'm going to have the 3 times x squared will be plus 3x squared. Then I have 3 times 5x, which will be plus 15x. Then I have 3 times negative 1, which will be negative 3 or minus 3. Now I'm going to combine like terms. So I have a squared term that's like, I have an x term that's like. So a little bit more going on in this one than the other. So 2x cubed plus 10x squared plus my 3x squared will be 13x squared. And then I have minus 2x plus 15x is plus 13x minus 3. Then don't try to combine unlike terms or do anything more with that. That's your answer. Okay, so we have 2x cubed plus 13x squared plus 13x minus 3. So 13's there. This next one, example 6.33, you can skip it if you want. If it seems a little much right now and you want to go back to it later, you could try it on your own. If you do that, you're going to take this first trinomial is 2x squared minus 6x plus 1 all in parentheses times parentheses 4x squared minus 2x minus 6 all in parentheses. And you would just, multiply that first term in the first trinomial to every single one in the next. And then same here, second term, multiply through, and then the last one as well. So you're going to have a lot going on in that one, so it's good practice. I will do this one, but you can, it's optional. I'll just write there if you want to move on and it's tending to take you longer, then skip it. If you want to try it, pause and try. Okay, so I'm going to do it relatively quickly. So we have 2x squared times 4x squared is 8x to the 4th. Then we have 2x squared times negative 2x is going to be minus 4x cubed. Then we have the 2x squared times minus 6 will be minus 12x squared. Now I'm looking at this middle one. Negative 6x times the 4x squared is going to be minus 24x cubed. Negative 6x times the minus 2x will be positive 12x squared. And then we have negative 6x times negative 6 will be minus 36x. Gonna make sure eyes go wonky after a while. 1 times this 4x squared will just be plus 4x squared. Then I have 1 times negative 2x is minus 2x. 1 times negative 6 is minus 6. Now, hopefully I've gotten those all correct. So look through. You can let me know if there's any issues. Sometimes I'll look at them so long, my eyes go blurry. Okay, so then we have the cubes that we can add together. We'll have the squares here. And then we'll have our, let me get another square. And then our x's. And we just have one constant in 1/4 power, so I'm not going to track those. I'll just carry them down. So we have 8x to the 4th. And then I have minus 4x cubed minus 24x cubed. So I have minus 28x cubed. Then I have minus 12x squared plus 12x squared. That's nice. That gives me 0. So I don't need that one. Those literally just cancel out. So I've done those. Now I have the 4x squared. So that's got to be there as well. Then I have 36x. Or minus 36x minus 2x, so that's going to be negative 38x or minus 38x. We'll just translate that. Then we have our minus 6. That's our answer. Okay, we could, if we wanted to simplify this one, we could pull out a common factor of 2 to be in front, and we haven't learned that yet, but just saying later, like that is the only thing I would really do to this. You don't want to end up back where you started from. You do want to think how you got there. We don't have you factor big, huge ones like this though in this class, so no worries there. All right, there's one more problem to do. And again, this is, it's kind of a longer one, so if you're just want to hold tight to what we've done so far, you can skip this one, but it might give you good practice. It's actually not too bad. So I'm going to say you can try it as classwork or as an example. So as an example, I would do the binomial first, multiply those. So I'm just going to leave my 3x off to the side there. Don't forget to put parentheses though. Then I'm going to do my x times 2x, and I'll get 2x squared. Then I'm going to do x times the 5, so I get plus 5x. Then my insides is negative 12x, and my outsides are negative 30. I think I got them all. And I do want to combine like terms before I distribute this guy. So then I'll have 2x squared minus 7x minus 30. And then I'm going to distribute this to 3x to all those terms. And I get 6x cubed minus 21x squared minus 90x. And that is that. So that's it for section 6.4, multiplying monomials and binomials, and actually more polynomials like trinomial times trinomial we did also. So a little misnomer on the title of this section there, but I hope you found that helpful. Let me know if you have questions. And again, the last two, if they were just too overwhelming, don't worry about those. Maybe go back to them later before you take Math 99. We do review this whole thing again more intensely with bigger, polynomials and stuff like that. So you'll definitely get more practice with that. So make sure you get the foundational skills. Have a great day.